Can you hear us okay?
Yes.
I hope I'm audible for I hope this is better. Hey guys, so I'm looking forward to questions and more interactions during this session. So let's make it a little bit interactive as well. You can post your questions definitely just ask, but maybe it would be good like if you want, have some, like if you want to share something out of curiosity, it's a small thing, feel free, okay? So yeah, let's begin. Data science thing, which was very much in demand these days. So the agenda is going to be like, we first talk a little bit about data science, then we'll see what a data scientist does. Then we'll look at the 8 steps of data science, like the projects which we do in data science, the latest 8 steps, and then what it takes to be a data scientist. And then finally we'll see, if possible, in this session, what AWS Cloud can offer for data science, and then we conclude this. So first thing, let's talk data science, guys. Let's do some excitement. So the thing is, we all gathered here, we did all the setup and joined, we were excited to listen to this tech talk. And it's because of the topic and also the thing is, why are we talking about data science so much? Like, why this buzz all around? Like, any like biggest question is this, like, why do we want to talk about data science? Anybody wants to take this, wants to share their views, like why exactly this is going to be interesting to know more about data science? Why should we have this discussion today? Any volunteers? Okay.
And it's going to be present and future. Data is everything.
Oh.
So data going to be present and future. So the data is going to be everything. So to drive whatever is going on, analyzing what the users thinking, and also thinking on future, how we can innovate, right? So it might be how we started with nothing, then machine learning, artificial, everything it started, right? So the data, how we can use the data and create models.
Yeah, that was a nice answer. But yeah, the thing is, why did this all came into picture? Like, why did we even think about analyzing data? So, is this my working properly? Yeah. Cool. Okay. So the thing is, so every day we are roughly creating 2.5 trillion bytes of data. Google processes more than 20 petabytes of data every day. This includes 3.5 billion search pages itself, right? So if you see that more than 306 billion emails that are sent every day, 500 billion plus tweets, and altogether, if you see, currently we are actually producing 45 zettabytes of data in the world every year. And it's going to be, if it goes like this, situation doesn't change, we keep on moving ahead, it's going to be 175 zettabytes by 2025. So the thing is, it's huge. We are collecting lots and lots of data. It's becoming huge, it's becoming complicated. It's audio, video, text. And there's a variety of data these days, right? So things are becoming complex, and as you guys know, complex things need science for it, right? So we need data science. So that's the thing. Data science is the new oil, as people say, as Nagarjun, you also have it. Okay, now we talked a lot about data, that we are collecting petabytes of data, zettabytes of data, that's fine. But is all that data really useful? Like, data are just raw facts, right? But we can't use everything around us. Even right now, we are having this tech talk, we are producing a lot of data in this room itself, right? But not every data is useful. You need meaningful data to utilize to make, to create some value out of it. It's not going to be like there are like petabytes of data and it's all over itself. You need to extract that oil out of data. So for that, this data science, the field of study came into picture when we wanted to convert this normal, this raw fact, which is huge, you want to convert it into some meaningful data and then extract some value out of it. So that's where this field of study came into picture. We started learning it, became popular, and we are having this TikTok today. Okay. So from definition point of view, data science is the field of study that contains domain expertise, programming skills, knowledge of mathematics and statistics to extract meaningful insights from the data. That's the motive. You do a whole lot of things. You learn programming skills, you use tools, you use AWS services, apply statistics, mathematics, but the ultimate purpose is use the raw data, convert it into something meaningful, get some insight out of it back, bring value to your business. That's the ultimate goal. Okay? And in this course of converting that raw thing into something very valuable, you apply things like machine learning, deep learning, to create some artificial intelligence that could actually, work on these raw things and apply and get some human intelligence out of it. So, when you have to apply something human-like intelligence on something which is their raw data, then you need to have something with artificial intelligence that could act like human. Like humans can do the same thing on small bits, but we want to do it on a huge thing on a regular basis, on a continuous basis. You need something called artificial intelligence, right? So data science projects do need machine learning and artificial intelligence for processing that data from raw to something valuable. And as I said, in turn, the ultimate goal is to create some tangible business value. Yeah, so I think I did talk a lot about machine learning and artificial intelligence in between, and it might confuse. Like today we are talking about data science. So where does machine learning, artificial intelligence come into picture? Okay, and you might have heard or seen tutorials which are like completely different for artificial intelligence, different for machine learning or data science as well. So how these things are connected. So as you can see in this Venn diagram, data science is that shadow thing, and this yellow shades are the ones that are like showing artificial intelligence domain. So first of all, as you can see, artificial intelligence has machine learning as a subset, inside which there's another subset that's deep learning. So that's one thing. Another entire circle is for data science. So the thing is, like I'll give you an example, okay? Consider artificial intelligence like food industry, okay, which are producing food. Data science to be the hospitality industry, like the hotels, where you can go ahead and have some stay in some of them, you can have services and all those things. But food is a critical part of the hospitality industry. They offer food as well to the guests, okay? So artificial intelligence is that food. Artificial intelligence can stay separate from data science as well. Like you can have takeaway counters, right, for food, right? So you can just go ahead and just grab something or get see as well in India, right? So that is food. That has another variety of food. Maybe machine learning is a South Indian food. We eat those and everything. And deep learning should be specifically elite, okay, for one thing. On the other hand, data science is the whole hospitality industry. You can just go here and you can just go to the hotel, don't eat food, you can come with just staying there, have some room service and go out. You may not eat. But yeah, sometimes you'd also need to eat, right? So maybe you need to have some machine learning, deep learning included in your data science project. So it does go hand in hand. I'm just trying to figure it out. Okay. I'll find better. All right, so we have been talking a lot about data science. The thing is, who does all this thing? And we tag that person as data scientist. And literally, I think everybody has heard that. Sexiest job of the 21st century, isn't it? I don't know whether people believe it or not, but we all have heard it at least once. Okay? The thing is, what this guy does actually, why is so sexy? Okay. So let's see what this guy does, okay? And then we try to do the same. A data scientist is a unicorn that bridges math, algorithms, experimental design, software engineering, communication, and management skills. It's a whole lot of things. company can do that. That's why there's a small, another statement, extended statement there in the code that they can't, if they aren't specialists in every aspect. They can't be expert in everything. They do a whole lot of things, sexy jack of all trades. They are not expert in everything. They apply all the different kind of skills to get to a point where they can get the value in the business. Okay, and whatever it takes, they have to look into the domain. They'll research. They'll, if they have to work on a finance project, they'll look into finance things. For a bank, they'll study for the bank. They'll look into the previous historical data. They'll apply whatever it takes, like algorithms, machine learning. If they want to have some cloud services added, they'll look into that as well. So whatever it takes to get to a point where they can bring some value to the business, then okay. So they need all these skills to be put into one specific data science project to get to that business value. So yeah, this is a Venn diagram that reflects the unicorn in the center, which has all those things, skills like machine learning, maths and statistics, traditional research, subject matter expertise, traditional software, and computer science. So there's a whole lot of things for data scientists to learn. And like, if every person comes next, you have to get all these things together. So another very nice definition I found by Josh Wells, which says, data scientist is a person who is better at statistics than any software engineer and better at software engineering than any statistician. That's interesting, actually. Okay, so let's see how we can make that balance. Now, the thing is, what exactly this guy does. So we understood, okay, this is on a high level basis, but there's a few steps that I've put down there. I'll just quickly go through it. So they examine question that needs to be answered for solving a problem. They apply business acumen, analytical skills, bind, clean, present data, analyze large amounts of data or unstructured data, and then finally synthesize results and then communicate it to the stakeholders who can actually extract some value or can help them in strategic decision making. So that's the ultimate thing. Now, this is interesting. It's going to be the maximum time we're spending on these 8 steps. So over here, what I'm trying to do is like cover the 8 major steps in any data science project, right from the very beginning till the end. So we'll begin with first thing first, problem statement. So it doesn't look like a step, but it's a very critical thing for any data science project to be successful. Unless you have a well-defined, appropriate problem statement, you will never get to the value that you want. Because it will be like you don't have clarity what you need to search for. Okay. So the first thing before we start any data science project is to first get a very appropriate problem statement. As you can see over here on the screen, there are 2 examples. First problem is, can setting up a new manufacturing unit increase profits significantly? Okay, this is also a question that somebody can ask. Maybe some person, some CEO who owns or a manufacturing company can ask whether, okay, like, is it possible to increase the profit if I set one more manufacturing unit? This seems very question. It's dramatically, it's correct, right? But I don't think that you might come to a straight conclusion that, okay, exactly what this guy needs, where he's trying to focus. But similarly, if you read the second question that says, can setting up a new manufacturing unit for sensor devices, he specifies it that I want to specifically have a sensor device manufacturing unit, could increase the sales profit by more than 10%. At least he has a benchmark whether it's possible to increase it by 10% or not by the end of 2020. Now it has a time bound as well. So now this question makes more meaning out of here. So the data scientist can take it. He can actually relate to it exactly what this person is looking for. And then he can start looking into things like whether this is possible or not. Then look into different aspects we'll see later on. But this question makes more sense. So something of this sort. We need a question to be actually smart. The problem statement has to be smart. By smart, I mean specific, measurable, actionable, relevant, and time bound. So before you start any data science project, you first need to have a problem statement that is actually smart. All right. So once we have this proposed statement, I think what we need to do is to get a raw materials for it. And as we all know, raw materials be first data. Right? So the second step is data collection. Now this could be the easiest step or it could be the toughest. Okay, because that depends on whether you already have some data collected somewhere or you really want to have a new set of data created or from where you need it. Maybe you have to take some observations. Maybe you can refer to some library archives, or maybe you can find something on internet, on Kaggle, things like that. All right. So data collection, as I said, is one of the most critical things because that's a raw material based on what kind of data you collect, what kind of data you have. That will direct everything that you're going to produce ahead, right? So data collection is indeed very critical and most time taking as well sometimes. Like I think for one of the projects that we were doing in software methods, right? For that also data creation was very critical and time taking. Like most of the time we had to go and label the data and all. That was a time taking process. So as I said, that depends. Like sometimes you might get an already created data served at the plate and then you start analyzing that would be a lucky thing for you, but you have to keep that in mind that we have to somehow synthesize the data. So that's it. Data cleaning and data pre-processing, lot of this. So the reason why I put it here is, see, as I said, data is a new point. Data has value. Data brings money, right? So the money is here. So the data that you see on the this left-hand side, right, that has value. But before you spend it, you need to organize it. Like you can't just have a keep in your hands and throw it to some shopkeeper. You can't spend it like this, right? So data. So all that is value. Similarly, when the data you have is not organized, that indeed has value, but you need to organize it first before you do something out of it. Okay. So like this money, you need to first put it in stats. Okay. So that you organize, you have it like, okay, these are my $10, these are my $100 or whatever, or 500 rupees or 2,000 rupees or whatever. So data cleaning and pre-processing. So data can be messy if it has not been appropriately maintained, leading to errors that easily corrupt the analysis. These issues can be, can be values to set to null when they have a zero or exact opposite meanings or missing values or things like that. When you're trying to keep mathematical operations with fail, if they have a division by zero, right, or if there's a null value. So no matter if your data is there, if you have applied good algorithm on top of it, if the values are not accurate, not appropriate, if the value is corrupt, in that case, your analysis will fail. So third step, after collecting data, is to clean it properly. This will also take time. You need to make sure that everything is appropriately maintained, and then you need to pre-process. Like a normal cycle looks like this. So you import the data, merge data sets, republish the same data. And it's not a standard thing, but mostly it happens this way. Then you stylize the data, normalize, deduplicate, verify, enrich, and export data. I'm not going to go into very much details of these things, but on the whole, you just understand it this way that you have something, scatter it, you just need to make sure that it has the right values, no zero, no null values, no corrupt values. So you just standardize something, let's say you are recording time. Few times are in minutes, some are in seconds, some are in hours. You can't use it. Like you can't apply a single component for minutes, hours, or what do you call them, seconds, right? You need to convert all the time into one specific unit. So all that things comes under this data cleaning and data pre-processing. Okay. So first we do cleaning, and then we do data pre-processing, where we do the transformation, normalization, and all those things, and make our data completely ready for the next step. After this step, you are actually, have heard your gun. You can fire you. Okay, now this is very interesting, and it is the point where this how good a data scientist is reflected, and that is EDA, exploratory data analysis, very critical step. So EDA is the point where you have your data ready. Now you need to understand your data very in depth. Like you start analyzing your data, start looking into it very close, try to relate to your data, try to get to know your data as much as possible. So that, okay, see, you have to get insights out of your data, and maybe you have got something in GDs, right? So just by looking at 5-6 rows, you can't understand anything. You can't understand what would be the outliers. You can't understand what would be different in this data, what kind of pattern you is. So now you have the data, but now you need to understand like what it looks like. You need to familiarize yourself with that data. Okay, so this is the point where you start drawing graphs, you start looking for scatter plots, you start looking for things with outliers, things like some kind of pattern in the data. And this is actually one of the most critical things, because unless you know your data, you can't get to a point where you can say that, okay, this column or this specific feature in this data could be the one that I can use or that I need to look into. So this is where you familiarize yourself with data. So the idea is to get a deeper understanding of data by looking for some interesting patterns or observations into the data. This is when we try to explore statistical characteristics of data, create charts, and test our hypothesis. Yeah, this is also a very interesting thing. So normally EDA people do it 2 different ways. Okay, like if you don't have any hypothesis, like let's say the data is completely new to you, has been straight away thrown at you, and you're trying to just know about it. Start drawing graphs, start looking into columns, number of rows in specific column, what's what kind of graph we are having for specific values and things like that. So it's like you're doing some blind exploration just to know your data. Another would be you already have a hypothesis. Okay, like you feel like I know like this is my company's record. I know December sales had went down, and I think I should look into it whether it's my hypothesis right or not. So maybe you can have multiple hypotheses already in your mind, but you need to test it out. You need to verify whether it holds true or not. So in that case, you also try testing those hypotheses during this step. Okay, so 2 things: you explore the data blindly to get to know it properly, or you have some hypothesis already in your mind. You draw graphs, you do some statistical operations, correlations, or whatever you need, and just verify those hypotheses, test it. Okay. I won't read the second paragraph, but yeah. Okay, next step, feature engineering. Okay, so after EDA is done, now you know your data very properly. You know what columns are there, whether they're minutes, dollars, sales, or whatever the data is. Now it's time for you to find features out of that data. Okay, and one more thing, this feature engineering and data, EDA goes very much hand in hand. Many times what happens is that you finalize the feature, and maybe then you have to go back to EDA and do some more EDA to come back here, look for new features. Okay, so I'll explain what features are actually in data. But assume it like this, that feature engineering is a process of selecting, manipulating, and transforming raw data into features that can be used to train an efficient model. Okay, as I said, now we are going on to that, preparing for the machine learning thing. Okay, so now for machine learning, you need some features that you would give as an input to your model. So that's where feature extraction comes into picture. So just an example, okay? So look at this. Over here, we have some data where, let's say it's New York, where 2,400 square footage can cost you 9 million, just a hypothetical data, okay? And 3,200 can cost you 50 million. So like multiple people have written, given their square footage area and the total amount you're paying for that square footage area. It's clean, it's all in millions, everything is proper, but it doesn't look that relevant. Okay, like the price is very different. For 200, like 2,400, you're getting 9, 3,200, you're getting 15. You're not able to relate to it company. Maybe this doesn't look like a good feature for me. I need to create some more feature out. So maybe I can do this cost per square foot. Okay, so now according to my first row, cost per square foot is 4,150. Then we have 4,944, 3,950, 510, and 3,600. Now you can see, like mostly the cost lies somewhere around 4,000 to 5,000, but this 510 doesn't make any sense right? So maybe this cost per square foot could be a better feature to apply for your analysis rather than using the amount directly. Okay. So, and because this cost per feature is actually including both square footage and your amount. So using these two rows, I created a new feature that I can use as an input for my model training later on, just to get me some cost predictions. So that's how we create a feature. There are multiple ways of creating such features. You can have feature extractions where you can apply principal component analysis, nonlinear dimensionality reduction. Other things like feature selection could be done. There could be certain columns that would already be in a certain format that you can directly use as features. So you can directly pick those columns. Maybe imagine if this square footage thing would already be existing. Let's say amount was not there, only cost per foot was already there in the data, then you did not create it by yourself. You don't need to apply any mathematics or division. So you can directly use it. So that's where you just do the feature selection, feature construction, the way we did, or feature learning. That could be done by some methods like Davies clustering or things like that. So I'm not going to go into very much details of these things, but I'm just trying to give you a high level understanding that once you have done the EDA, it's time for you to pick those specific data columns or things that we can use for the prediction. Not everything. Like, let's say if you are having an employee record, name of the employee will not be used for any prediction. Doesn't matter whether your name is Priyanka or Balaji. Okay. So any XYZ could be there, but maybe some profit data could be used as a feature. Maybe your retention data, attrition data could be used as a feature. So you need to extract those things first. Sometimes you can create those things out of the existing data that you already have. Now, thing is, once you have finalized your feature, you know what exactly you'll be using from this data. Now it's time for you to create a model that will help you, get to a certain result or make a projection or prediction. So the next step, as you can see, is model evaluation and training. Now, as I said, evaluation first and then the training. There are like plenty of models out there, many ready-made models, some like AWS services providing some ready-made model as well. The thing is, which model would you need? Like you need to use, like you have to make the selection, and that's very critical. You can't use any random healthcare model or any biometric model for your sales data. You can't use any financial bias model for your healthcare data, right? So you need to pick, you need to have an evaluation done first, like exactly whether this model will fit as per my data or not, whether my features that I've selected will go with this kind of model or not. And then I'll do the evaluation and then further go for training. Okay. So this stage is all about building efficient machine learning model that best solves your problem. Maybe multiple models can solve your problem, but the idea is to find the best fit for it. Okay. And sometimes what happens, you need to create that entire model by yourself, or maybe you can reuse something that is already existing. Like 99% of times, people reuse something that's already existing because we have done already a lot of research in this domain, and there are multiple models existing that you can simply use, give your features as input and get the results. And maybe you just need to customize it a little bit as per your data, train it, tune it, and then make use of it. Now, the thing is, the biggest question which people not familiar with data science would ask, what exactly a model is? Is it like a robot or something or whatever? Like, what we feed it? How, like, why is it? Model is nothing but a mathematical representation. It's equation. Okay? Equation could be as simple as y is equal to mc plus x, like the equation of straight line you might have learned in school. Or it could be very complicated, like a polynomial part of the x, some n minus 1 to the power, something like that. Okay? Something of very polynomial type of part in your back to x, and some kind of very complicated expression could also be a model for you. But ultimately, what your model is basically an equation. Okay, why am I saying this equation? Because imagine like data are simple points, right, which you can plot on a graph. All right, so imagine there's a 2D graph which you guys must be using in your school, and let's say you have to plot 5 on it. You'll just see where the 5 lies. pointed. Maybe there's another point which is 0, comma 2. You go ahead and point it, right? Similarly, whatever features you have extracted, you just need to go and point it on that specific 2D graph. Maybe the way I'm doing it here. Okay? So I took a graph, I pointed, I drawn all the points on that graph. This I can do programmatically. I will EDA also. There are certain code that you write to have your data plotted this way. And now after looking at this data, I don't know, I feel like it's going like a straight line, isn't it? All the points are very much kind of straight. See, you don't need to pass the entire thing, cross that curve or zigzag. Just need to see how this data is, looking like. It seems more of like a straight line. So what I do, I just say, let me put a straight line into it. Okay? With a certain angle that will pass through maximum point that I have drawn on the plot. Okay? So I have drawn this line, and maybe the equation of this line becomes y is equal to 1.59x plus 9.5c. That's right. That's not calculated. But imagine, okay, this is there. So now this line with this certain equation becomes my model for this specific data. So let's say if somebody gives me some point in the future and asks me what could be the prediction, what I'll do, I'll simply project this line further and see where this could be, gotten to this point where my line will be, and I give the prediction as per that line. I will not look into the specific data points, but now I'll give all the prediction based on this equation of line. Okay, so and actually this example is the simplest form of model in machine learning, which is called linear regression model. There are multiple other models as well, but this is the linear regression model of machine learning. This is nothing but something that acts as a straight line is your model. Okay, which has certain. That's what a mod is, guys. So don't think about anything else when it comes to mod. To make it more clear, like y is equal to 1.59x plus 9.5 is there. Y is your output, that the prediction that you will get every time you apply some kind of x as an input. So that after 1.5x is your input variable, so whatever you apply goes there. Then there's a constant, which is your c, and after you just do this addition, whatever answer you get is your output or prediction that the model is trying to get. That's it. Okay. I hope it was not very mathematical.
I followed it.
Oh, right. Yeah. Yeah.
So if that is the simplest way of looking at a model, what is the complex way of looking at it? Like very briefly, if you can explain it, not
Yeah, sure. Like if you can draw quadratic lines or maybe plots or sometimes let's say something that would act like a bell curve, that goes to your model. Right? So ultimately, a model is going to be a mathematical representation. That will have some mathematical representation. It could be quadratic equation, it could be a polynomial, it could be x to the power 5, 6, 7, 8, whatever.
It will still be an equation.
Yeah, that all your models will have an equation definitely. It could be very simple as a straight line. It could be more complicated as well. Okay. So altogether, we have these kind of models on a high level: supervised regression models, supervised classification, and unsupervised models. Just name these things. It's not going to go details, but that's there just to keep a reminder. Supervised, unsupervised, supervised as regression or classification, and unsupervised. So it's there. So this session maybe. So yeah, so just sorry.
So it looks like everybody's solving the models now. So
Trying to write the equation at that time. Tell the slope. It's making it right. Okay. So just let me read this once. Just summarizing it. So this stage is all about building a model that best solves your problem. You can even use an existing standard model by adjusting a few parameters. We try to fit the best combination of weights and biases, like those X and C and all those things, to machine learning algorithm to minimize the loss function over the prediction range. So it's like, see, straight line can be anything, right? But you try to see which C would go best for your situation. Maybe your straight line needs to be like this, or this, or this, right? So you need to adjust the slope based on that. Similarly, have the model ready, now deploy it, get the job done. So deployment it could be done using Python frameworks, which I always advocate a lot because I've used it. Sorry, that's my bias. So using Django Flask, it's very easy to write your models and deploy it. Or you can, of course, leverage cloud function, AWS sites bias. That is also there that you can use, and I think we did use for things in software. So there are multiple other services that you can use depending on your needs and subscription level. So either you can deploy it via cloud or via Python frameworks. Ultimately, the model looks like this, where you create an HTTP point, either you do your web hosting using Fast or Django, or serverless, use AWS Lambda, cloud functions, Azure functions, or you can directly use something which is already there as a service available to you. Like in AWS, the SageMaker is there, right? So you directly go and write your model everything over there, do your EA, over there, you do all those things right there in your cloud, and it will be deployed in there, right? So depending on your need, your usage, your availability of resources, you can pick and choose whatever suits your needs. And the last step, the final one, which is the actual thing. Like no matter how much mathematical calculations you did, no matter how good your analysis was, if you are not able to communicate that result properly to your stakeholders, if you're not able to get to the business values that you wanted from your thing, then you will no longer succeed. Okay? So communication is very critical. You have to make sure that whatever findings you have done or have got from the machine learning model, from prediction, or from the analysis, you need to communicate it properly to your stakeholders or whoever is the person who's trying to get the business value out of it. So that's the final step and one of the most critical and ultimate goal of this entire data science project. Okay, so it is very important for data scientists to communicate their findings to those without technical backgrounds effective, because many times you see that people who are in the strategy side or element side who really needs that insight may not be very technical. So you can't just show them the expression and the graph, it looks like this and that. You need to have a story for it, right? You need to tell them in a way that can be understood properly. That's the last step. That's a key step. So for explaining those complex concepts, you need to find a way out that will be understood. And ultimately, that will decide just the things. I think it's already 11:45 now, so stop here. After this, I had a few other things that what it takes to be a data scientist. Maybe I can give some tools, skills, practice, and what all these you would need to become a data scientist in parallel to that software engineering. As I said, it goes hand in hand. You need to be a software engineer to be a data scientist. You need to be a data scientist also, like along with the skills and scope, goes like that. And then we can cover a little bit about data science and AWS cloud, like what are these AWS cloud can offer to us. So we can talk about these things sometime later in another second part of this session. That has to be continued. Okay, that's all. Thank you guys. Hope you all enjoyed it. Get more guys.
Yes, we have one question in this task. The question is how do data scientists get data? Is it user? How is data generated?
So as I said, like data is getting generated from many different sources. Data could be audio, video, could be images, text. The email is also data, right? Somebody, maybe you're purchasing something from let's say some shop out here, okay? And maybe they are using your data, your customer, your purchase history, has something to analyze their sales, so maybe it's something to you that you might buy in future, right? So data could be anything. It could be produced from sensor devices, in some manufacturing units, in some somewhere in planes or whatever, or you can simply have some purchase data, historical data, memory, medical data. So it depends on where it is coming. Sometimes you might have to create your own data. Let's say you're trying to solve a problem which was not even thought through properly, which was not even existing. The solution was existing there. So maybe you need to use some sensor devices to collect that data. So that is very much depending on the kind of problem that you're trying to solve. That's why the first step of any data science problem and data science project is problem statement. You define your problem first, and then you look for the data which is relevant to your problem statement. Okay?
Jayanti, I do have one question for you. If a person has to start his career in data science, what is the starting point? Where should I start?
I think we all have started already. Like, as I said, like people need software engineering skills first of all. They need to understand computer science, and I think many of us already do here, right? You need to have some understanding of statistics and mathematics. Like you have to look at equations and graphs and all those things. You need to have that understanding. And then further, if you have these two core concepts, you go ahead and start for some one language, at least R or Python. And then we have some tools that where you can use some sample data which is available online to start practicing. And then maybe you can take up some pure like problem, start analyzing good things further. So gradual steps that something you take depending on interest, of course.
If I don't know coding, can I do it?
You can use some tools like Tableau or something for data science because they have these sources already built in. So with very minimal understanding of computer programming, you can still analyze data if you're statistics. If you have things like that, but that still has lots of limitations. But at least you can get to a position where you will be analyzing data to a great extent. Questions?
I have a question. So how this SEO, data analytics or data science can contribute much more to SEO side? Right now we have done everything in Google Analytics for substance, so right now we're doing the SEO. So is it a platform we can
Research and optimization. I think Google's already doing that.
that's the only one we have.
I'm not able to properly comprehend the question first, but as far as SEO is concerned, I think Google guys already do that. They see whatever would be the most relevant links to your, depending on your history sometimes also. Like, let's say if I stay in Delhi and there's a restaurant, I try to search, that restaurant, the same name belongs to restaurant in Bangalore. But if I do a search at Delhi, I first get to see my restaurant which is close to my place. That's where they are like, trying to analyze, okay, where this person is belonging to, whether the geography is location, and then based on that, then showing that results. They are also analysis on the go. They have done some algorithms that will help you optimize your search as well. So I think they are doing it already. And of course, they'll be improving it further, but like I said, those advertisements are there, but that's fine.
There's also other tools that make complement it, but Google. I think that there's other tools also that complement search and optimize, but kind of other tools, right? And this is built around that too. I think that we can also take that into the analytics aspect of it. Right? There's some limitations. The other tools any out there depends if they come. That's what it is. Other platforms out there as well that do a lot more than one.
So in most of the projects of data science, we got to see that the Python language is being used. Even today, whichever like data science project you take, Python is like a root level thing which we need to learn. So first, like the question is that why is that so, and like can we use our own language whichever we are like using to program? And the second is like, let's say if the answer to the first is no, then like is it like completely mandatory to learn Python and go ahead?
Web developers, please answer why JavaScript is important. See, JavaScript is the key that keep it developing. It's like the browser, you can't help. Similarly, to get to that competition, Python created those libraries, created those packages that will help you analyze data much easier. It has a lot of higher mathematical applications as compared to the other languages. Okay? So this has created an edge. There was another language competing that was R, But as I said, because of that community support, Python today has been so much mature, so much relevant for your data analysis that any person who sees about it will definitely go and learn Python first thing, right? So that's how the world runs. JavaScript for web and Python for data science. But Python is easy to learn. If you guys are doing JavaScript or other languages, Python is definitely easy. You can just try it out once. Syntax is very clean and simple to understand.
That's it.
That's it.
Yes. Yeah.
Yeah, so first step to like since it's like gathering all the data, right? Cleaning the data first. You need to have like enough data to
Third step. That's the third step.
yeah.
Yeah.
So let's say if like in future like we have this Web3 and what is coming up, stop giving the data into any company or any organization.
It's
So
not giving
I
data.
mean like Web3 is kind of a decentralized data kind of right.
Yeah,
So
yeah.
like if any company or stop giving data. So what happened to this data? Like is it still relevant?
See, as I said, like, first of all, let's say you have a certain problem statement, and if your company is trying to solve a problem statement, if some organization is trying to solve a problem statement, they will first make sure that you get the resource, right? So, I mean, look, depending on the question that you're trying to solve, you first see whether you can find the raw materials or not. You can't like start building a car if you don't find the middle market, right? So either you find it or you create it. If you don't have it, you create your own data based on the known data that you have. So your own observation, you do whatever it takes to have those connections ready. So either you find it, your company provides it, the organization that's giving you the problem statement provides it, or maybe they'll ask you to create it using some means, right? So yeah, depending on the problem statement, you find that way. And if you're trying to understand whether you can find something relevant for learning purposes, in that case, there are definitely some open source data sets available in the market that people call students and things like this. When people use it now for learning purpose, their healthcare data, their financial data is available, or historical data without any specific recognition or names of any person involved into it. You can use that data for learning if you want. You can find a lot many data sets on Kaggle where companies deliberately post the data along with the problem statements that somebody is at some position before it's a good data scientist to solve and they even have prize money for it. So you must have heard about grandmasters and Kaggle, right? So people are doing those things like that. Okay?
So to what step of data science statistics is mostly applicated. The knowledge of statistics comes handy.
Yeah, you need the basic understanding of statistics. I would not say only statistics, but statistics without understanding statistics, you can't do the analysis because you have to plot those graphs. You have to see. You have to, let's say, you have to calculate the principal component analysis. You need to have the core understanding. Maybe somebody else can do this one, or maybe you have a tool that will create those graphs. Maybe you can write a program for doing that. But at least you need to have that knowledge that when to apply what formula, when to apply, when to create what kind of graph, what kind of data I'm having, whether a line graph will work over here, whether a bar chart will work over here, whether a histogram will work over here. You need to have that understanding, right? So statistics is definitely one of the core concepts that somebody needs to know before getting into this field.
And like for a project manager, if they have to manage a data science project, then what are some of the skills that they would need? And definitely they are not going to create models and but what are the common things they can acquire and skills like to manage this particular understanding?
Okay, that's an interesting question. I have to dive into that project. How can Science help me out in science project? Okay, so I think maybe they can help me first of all create a appropriate problem statement because that is something which anybody who is having good business understanding can help. Okay, so maybe their project managers could play a very important role. Second, when it comes to EDA, like once the problem statement is ready, somebody else is collecting data. Maybe that type of project manager can also help. They can help you get that data. Can also help you label that data. Can also help you find the resources or connect to certain things, or connect to some other teams or other organizations, facilitate the data collection. That's where project managers can help. Cleaning and pre-processing engineers will do. When it comes to EDA, they will definitely draw some graphs, they will test the hypothesis. Maybe they can discuss some hypothesis with the project managers, what they think. They might also have some understanding, right? They can also give you some examples. You can also share your results with them. So maybe that time, if your project manager is capable of understanding things by looking at the graphs, just that they're not drawing it, but if they can understand that okay, graph is showing this kind of thing, and this data scientist saying that okay, see, this is what is happening, this is where the outlier is, all the points are here to the right, and these 5 points are to the left. In that case, maybe those discussions could be facilitated by the project managers. Okay, so that when your engineer is doing the feature extraction, that time they will be double sure that whatever features that they're selecting has this just definitely be valuable in future. So these are the points where they can help the teams, and ultimately when it comes to communication as well, a project manager can come in and help them, communicate those results more appropriately, relevant to the stakeholders and all those things, right? So that's where I see project managers can be very helpful to the team who's having more business understanding and transparency.
Based on the hosting methods, we have to get the data from the client. So he used to send us the data in terms of the needs. We have to categorize that and make sure that we map it correctly to the respective categories. So that was one of the points, where I guess as a PM I had thinking sort and put the data in the organized way that could be pushed by the team. And as Jayanti just mentioned, and EDA, so that's also one point where we could get.
Adding point to that, so what Shivam said, like how works based on the statistics of something. I can tell some real-time incident that how the statistics can help. So, for example, you can take a companies like Horlicks, Boost, or something like. So we are buying 250 grams of a bottle, but if they want to increase the sales of that particular thing, so they were asking the data scientists like how we can increase the sales more of it. So they were taking the statistics of gathering the data of the history of when their product has sold. And so what is the exact problem we are facing? Why the sales is not increasing? Do we want to increase our product taste or something? But actually, the data they have is like they are selling from this year to this year, and which are the areas they are covering. So they are coming with the answers that we have to cover more areas, and they are coming with the solution. We have to pack it with like 100 grams, 50 grams, and we have to keep it some of those. So those data also take, but still we have that statistics. But the actual problem, they follow. The problem is somebody bought 250 grams of it of a packet. It is taking more time for them to get finished. So the exact problem, the exact data they want is how many spoons everybody they are using for one glass of it. So that was the exact data they were looking for. So they found out the solution is they given the same water, they given the same amount of gram, but they increase the size of the spoon. So they increase the sales of that of 10% in 3 months. So they actually got more.
That's very interesting. Very nice story. Thanks, Anurag.
Yeah. So this is how the statistics works. Like you need the statistics and details, not only the history. The problem, exact problem statement what you are looking.
Yes, definitely. That really is all about statistics. So that example was really nice. Thank you for sharing.
Okay, another question from Jessa. Do you have to be a very good programmer to be a
You need to be good at programming, at least in one language. 5 minutes.
All right. So any other questions? Okay. Okay then. A big round of applause for Jayanti. Okay. So another update is we'll be posting the feedback link in the group. So please say give us your feedback. How did it go? How can it be done better? So we can do it better. And the rest will be continued in the next TikTok. Yes. So the people who are online can just stay on the call. We'll be continuing the company wide in the same link. And for the people here, teas and biscuits are served outside. Just take a 2 minute break and bring up. Yeah, people who are online is good. Thank you.
Oh, thank you.